Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to solve a system of differential equations that has repeated eigenvalues. So let's take a look at this. So instead of writing out the whole equation, the matrix that we're working with is A equals 0, -4, 1, 4. That's by columns, and we'll have an initial condition of 6, 2. So let's start this problem as you'd expect. Notice our characteristic equation is lambda squared minus the trace. Well, the trace is 0 plus 4 lambda, and then plus our determinant. Our determinant is going to be 0 minus -4, which is 4. And notice this factors into lambda minus 2, lambda minus 2, and that equals 0. So I have the problem that lambda is just 2. So what that means is then I'm only going to get one eigenvector. Well, let's find our eigenvector. So we find that by taking a look at A minus 2i times V equals, that's going to give me 0 minus 2, 1, minus 4, 4 minus 2, times V equals 0. And it looks to me like if I took the first column and I added twice the second column, that would be 0. And so I'm just going to say that my eigenvector is 1, 2. That should work. Okay. Now, so I can very simply, I can write my y1 solution is just going to be some c1 times the eigenvector of 1, 2. Times e to the 2t. Okay, now I want to show you something. This isn't a solution, this is just the rationale. So if you said in before, we would say, okay, well, y2 then is probably some c2 times the eigenvector of 1, 2. And actually, just for illustration, we'll do that, times t e to the 2t. Well, let's just see why this isn't the case. So y2 prime is going to be c2 times my eigenvector of 1, 2, and then we're going to have to take the derivative of t e to the 2t. That's going to be t times 2e, the first times the derivative of the second, plus the derivative of the first times the second. Okay, that's the left-hand side of my differential equation y prime equals a y. And so now let's take a look at a y. So a y, well, that's just going to be c2, and then a times y, well, that's just going to be the eigenvalue, that's 2, times the eigenvector, 1, 2, 1, 2, times t e to the 2t. Well, let's take a look. If I set these equal to each other and I expand, so y prime, I'm going to write this, y2 prime. Let's write this as c2 times 1, 2. I'm going to write it really clearly here, times t times 2e to the 2t, plus c2 times the eigenvector 1, 2, e to the t equals a y. Well, we just set up above that is going to be that's going to be c2 times the vector 1, 2, the eigenvector, times 2 times t e to the 2t. Well, now if we grab a highlighter here, let's grab a highlighter and maybe it's this pretty blue color. Notice that on the left-hand side that these two terms match, so those would cancel each other. So what I'm left with is this odd conundrum here of c2 times the vector 1, 2 e to the t equals 0. Well, clearly that's not the case. That would only be the case if C2 is 0, and so we would have no solution at all. Y2 would be 0, so that doesn't do us any good at all. So here's our correction. What we're going to do is we're going to use our variation of parameters. And we know we have some solution y1. Well, let's make that vector now. Let's make it a function. So we're going to write this as y2 is some function. We'll call it a1 of t, a2 of t, times, and we don't know what those are. We suspect, or at least I suspect, there'll be a t e to the t, but let's just run with our null solution. We're just going to follow the process of variation of parameters. So the first thing we're going to want to do is take the derivative. So y2 prime is going to be, we're going to have the derivative of the, so we'll write it as the first. So this is a1 of t, a2 of t, times this derivative of the second, 2e to the 2t, plus the derivative of the first, that's a1 prime of t, a2 prime of t, times the second, e to the 2t. Okay, and then let's do the same thing, but now let's write this as ay2. So that's going to be the matrix of A. Let's write that down again. That's 0, 1, minus 4, 4. And then we're going to multiply that by y2. Well, y2 is a1 of t, a2 of t, e to the 2t. Well, when I multiply that, look at what I get. I'm going to get 0 a1 of t, I'm just going to leave a space there, plus I'm going to pick up an 1 a2 of t, and then I'm going to, the row 2 times the vector, that's going to be minus 4 a1 of t plus 4 a2 of t times e to the 2t. Wow, okay, we're actually getting pretty close. So I'm going to write down, yeah, look at what we've got here. I've got, on the left-hand side, I'm going to circle some things, and we're going to go to another page. I'm going to grab a highlighter here. Let's take a look at this pretty blue again. Notice that on the left-hand side of my equation, I'm going to have, or if I could divide both sides of this equation by e to the 2t, so we're not even worried about that. But here I have a1 of t, a2 of t, so we're going to move that over to the ay side, over to here. And then on the right-hand, so on the left-hand side, I'll be left with a1 prime and a2 prime. And then on the right-hand side, what we're going to do is, notice that this on the right-hand side, this is just a vector. And now we're going to be subtracting off minus this vector right here. So I'm going to go to, and remember that vector is being multiplied by this 2, so minus 2 times that vector. And that's what we're going to put onto the other side. So that might take me a minute, but let's have you try to write that as well. So we're going to have the a1 primes on one side. So here we go. I'm going to try to get this all organized. So this is going to turn this off. So on the left-hand side, I'm going to have a1 prime of t, a2 prime of t equals, and now when I add these to the other side, I'm going to have a minus 2a1 of t plus a2 of t. And then I'm going to have a minus 4a1 of t plus 2a2 of t. Well, look at what this is. This is, on the left-hand side, this is a1 prime of t, a2 prime of t. And on the right, we have this matrix. We have this matrix of -2, -4, 1, 2 times a1 of t, a2 of t. So that's going to come in handy here in the future. But what I want to do also, though, is let's look at the system of equations for a moment. Or actually, you know what? Let's just take a look at what we've got. If I was going to if I was going to just treat this as a system of equations, which I'm going to, I could say, what if I was to take this is my pivot, -2 is my pivot. So let's say row 2 minus 2 times row 1, and let's see what we're going to get. So my augmented matrix is going to become a1 prime of t minus 2, 1, and then I'm going to get an a2 prime of t minus 2, a1 prime of t. Okay, that's a lot. I'm going to scoot those over. -2 and 1. And then what I'm going to have is 0, 0. There's my augmented matrix. Well, what does this tell me? This would be nonsense if if I have 0, 0 on that bottom row, then that means that the a2 prime minus 2a1 prime has to be 0. So we can do that. So this says that a2 prime of t minus 2a1 prime of t has to be 0. So let's solve for this. a2 prime of t has to equal 2 times a1 prime of t. Let's integrate both sides. a2 of t. This is going to give me 2a1 of t plus some constant of integration. We'll call that b. Okay, now let's look at this. Now, if I want to solve this, I could use, let's go back up into this equation right here. Well, this says then that a1 prime of t, is equal to minus 2a1. So minus 2 times a1 of t plus 1a2. Well, 1a2, that's just this right here. So plus 2a1 of t plus b, those cancel. And look at what I have. I have that a1 of t is equal to b times t plus another constant of integration. And we're actually pretty well done with the problem. Look at where we started. We started this from here. We said that y2 is some vector a1 of t, a2 of t. And let me see. Oops, oh, we're going to need our a2 yet. Our a2 of t. Notice down there that we said it's 2 times a1. So this is 2 times bt plus c. Oops, a2 is 2 times a1 plus b. 2 times a1 plus b. Okay, there we go. Now, so let's write, so now, I'm sorry, y2 is a1 of t, a2 of t, e to the 2t. Well, now look at what we wrote. We just said that a1 of t is b t plus c. And we said that a2 of t is 2bt plus 2c plus b times e to the 2t. But let's break this up. This is really, it looks like a linear combination. We have the vector. If I factor out a bt, well, this becomes the vector of 1, 2, b times t e to the 2t, plus I have another vector in terms of c's. Well, 1, 2, c e to the 2t. Plus I have one more vector, 0, 1 times b times e to the 2t. And there it is. Now let's take a look at what this really is in comparison to y1. We said that y1 is some scalar, we called it c1, times 1, 2, e to the 2t. Well, wait a minute. So when I look at y2 and I grab my highlighter, this term right here, this term here is really just this term here. So somehow that's part of my c1. So when we think of this, we look at our y2, what we do is we just say that c equals 0, because it's just going to be absorbed into the other null solution. And there it is. My y2 is equal to, look at what this is. I'm going to write the specific form and then our general. So it's 1, 2 times b t e to the 2t plus 0, 1 times b e to the 2t. And so b is just like our c1, but I called it b. I could have called it a c2. So there's my just general constant that's going to be affected by my initial conditions. And this is the in general form. In general, our second solution, y2, it's the eigenvector. I'm sorry, it's not that. It's some scalar, c2, times the eigenvector times t e to the 2t. There's the part you would expect, plus this 0, 1. It's not always 0, 1, but it's actually called a generalized vector, or generalized eigenvector, so we'll call it v sub. No, I'm not going to do it that way. I'm going to call it the vector A. I'm going to show you why. A times, it's C2, also C2, times this vector A, e to the 2t, where A, the vector A, has components of A1, A2. And now we don't have to use the of t part because we already saw how that all came together. So in general, we can just use this general form, find A1, find A2, and we have our solution. So let's just try this. I know this is a nice healthy length video with lots of good information, but let's just try it using our general form to see if in fact we get the same y2. So you see how to use it. I don't expect you to go through all of this derivation, the variation of parameters. Really what I expect you to do is would expect you to use our general form. So let's try that. So we would say that y2 is the vector, or is some scalar c1 times 1, 2 t e to the 2t plus that same scalar c1 times a1 a2 e to the 2t. All right, well, remember what we're solving. We're solving y2 prime equals a y2. Well, let's see what y2 prime is. y2 prime is going to be c1 times the vector 1, 2, times the derivative of t e to the 2t, that's the first, times the derivative of the second, 2e to the 2t, plus the derivative of the first, that's 1, times the second, e to the 2t, plus, there's our c1 again, times our a1, a2, a1, a2, times the derivative of e to the 2t, so it's 2e to the 2t. There's my y2 prime, and then let's look at ay2. So that's going to be c1, and then a times 1, 2, well, we already know what that's going to be. That's just going to be 2 times 1, 2, times t e to the 2t, plus we're going to have another C1, and then we're going to have the matrix of A. And the matrix of A is 0, what did I say? 1 minus 4, 4, I believe is what it was. Yeah, there we go. Times A1, A2. A1, A2, e to the 2t. Okay, now before I get carried away on this, look at what we can cancel right off the bat. We can cancel out this C1 times the eigenvector times t2 e to the 2t. This is on both sides of the equation. And so let's just deal with what we have left then. That's really all that's of concern. So on the left, and I don't need a C1, I can cancel that, and I can cancel all my e to the 2t. So on the left-hand side, I have 2a1, 2a2 equals, and then, oh, whoops, plus, I have the vector 1, 2, 1, 2, and then on the right-hand side, I have this new vector of a2, and then minus 4a1 plus 4a2. Okay, we're going to subtract the a vector over to the left, so I have 1, 2, equals, so now I have, this is going to become a minus 2a1 plus a2, and then I'm going to have a minus 4a1 plus 2a2. That looks a little difficult to see at this point, but remember this right-hand side is just this matrix of minus 2, minus 4, 1, 2 times a1, a2. So the question is, look at this. I need some combination of my first column plus the second column. I need to get the vector 1, 2. Well, look at that. I already have 1, 2 into the matrix, so there's probably a few different ways to do this, but I think the easiest one would just be to say that the vector A is just 0, 1. So 0 of the first column, 1 of the second column, and sure enough, that would give me my 1, 2. And there I have it. So now we can write this. We can write this as we have our same solution. So now we know that y2 is in fact C1 times 1, 2 t e to the 2t plus, or I guess these are C2 plus C2 times 0, 1 e to the 2t. Okay, now, you probably thought I'd forgotten, but we also said there was an initial condition to this problem of 6, 2. So let's solve that. So when we have the initial condition, notice that when I put in a 0, that this vector here from y1 and y2 is going to become 0. So really, all I have to do now is just figure out, is I have my eigenvector matrix of 1, 2, and 0, 1 times C1, C2, and we know that that has to give me 6, 2. And let's take row 2, and we'll subtract 2 row 1s. So that's the augmented matrix of 1, 0, 6, 0, 1, and then that's going to be a 2 minus 12. Oh my gosh. Did I do that right? Yeah, 2 minus 12 is minus 10. Hopefully something just seems wrong, but that's okay. We'll try it. So our complete solution, here we go, is y equals C1, we just found is minus 10, times the vector 1, 2, e to the 2t, plus our C2, which is 6 times 1, 2 times t e to the 2t plus 6 times 0, 1 times e to the 2t. And if we put in our 0, then let's see, this would be I have these switched. Holy cow. You guys should say something. This is 6 times 1, 2. Then I'm going to have a minus, there we go, minus 10. And then another minus 10. And notice that if we, at time is 0, we're going to have a 6. There's our 6. The other terms are 0. And then we're going to have 6 times 2 is 12. But we're going to subtract off 10. And there it is. And that is our complete solution. I hope that helps. And thanks for watching.